Welcome to Rust. Welcome to the Rust LA meetup. Welcome back for some of you, I hope. Herman had kind of some transitions and was changing jobs and stuff, and I asked to take over the meetup, but pandemic happened and that transition got very slow. But eventually he handed over the credentials to me, and I figured we kick off the new year with this talk from Jason. If you don't know me, I did come to a couple of the meetups, but my name is Drew. I run a small work-for-hire shop in the games industry called Game Breaking Studios. I do a lot of engineering there. I also do a lot of business development and all that other stuff that's not as fun. I'm a hobbyist myself. I don't use Rust in production, but someday soon, I hope. Someday soon, I can convince the team to use it. If you need to contact me, my email's right there. If you want to help out, which is kind of the next slide. If you want to help out, help me organize these, help me find speakers, help me run some of these events, feel free to shoot me an email. If you yourself have a talk or an event idea, you can use that short URL right there. So there's just a Google form. I believe that's how Jason got in touch with me, is he submitted this Google form, said, hey, I want to do a talk that looks like this. And I hope to be doing this every month or every 2 months, my schedule willing, and get some really interesting people slotted in. As a games engineer, I'm really excited to try and grab some folks from the game industry. I've been talking to the CTO at Ready at Dawn and trying to convince him to come tell us what they're doing over there with Rust. I think that'll be fun. And one of the organizers from the Global Rust meetup, or Global Rust, Rust conference, also got in touch with him, so hopefully he can send some fun speakers our way as well. And just as a plug to folks who help me pay my Zoom bill, the Game Breaking Studios is hiring for software development engineers. This isn't a Rust position, but we're taking people who know backend engineering and who know and/or game development. Also, AirChat is a new startup that's in town, and they're actually hiring for Rust positions, for a site reliability engineer that is actually a Rust position. You can use these emails here if you want to get in touch with either our company or theirs. I'll put all this stuff in the chat so you can find it at the end if you're interested. And without further ado, why don't you take us away here, Jason? I'll stop sharing and you should be able to take over.
All right, can you guys hear me? Can you guys hear me? Hello, can you guys hear me?
Yep, we can hear you fine, and I can see your screen.
Okay, you can see the screen. Okay, good. I have all. Let me try to. All right. Well. All right. So first of all, thanks, Drew, for getting this back and going again. I really appreciate that. Hopefully, like to see it going forward with a lot of participation. So my name is Jason Byers. I'm a contract developer at the City of Los Angeles. Started in 2008, been there a long time. And we are actually using Rust in a lot of places on our website, planning.lacity.org, which we're going to go through. So basically what I want to do is basically give you an introduction to the website, talk about some statistics. We have had a bunch of hacking incidences or contests and so forth on the website that I can talk about, and talk about how Rust held up during those. I'll go through the specific kind of places we're using Rust on the website. And I'll talk about how we actually are deploying these applications. They're basically Rust EXEs using the hyper library placed into systemd and reverse proxy through Apache. And then at the very end, we're going to go through some basic WebAssembly code. All right, so our website is a Drupal website. That was the director's choice. He knew it from where he worked before. It's in Azure with an Ubuntu operating system. The bulk of the data that is served on the website, because Drupal is like a content management type of architecture. So there's not a lot of programming you can do with it. So what we do is we have a lot of calls to APIs, and those are served basically on a C# application through IIS. Rust serves all of the documents on the website, and that's also in a separate Ubuntu server in Azure. And to manage the documents, we actually came up with using OpenKM, which is a Java-based document management system. But the problem is, one, it was way too slow, and two, the URLs had to have like a username and password in it. It was kind of weird. So what we're doing is using that structure, but Rust is actually serving the document. So we're using OpenKM to manage the documents, and we're using Rust to actually serve them on the website. We also have the search for our website is a full text search based on the Tantivy library, which is a Rust library. It's similar to the Apache Lucene library in Java. We also, on the website, we have 2 functioning WebAssembly apps, which we'll go over. And one of the main, there's a couple main reasons why we decided to go with Rust. One is Drupal takes over the server, right? There was no way for us to use PHP alongside Drupal, because Drupal's PHP based and you can't actually use PHP files. So we needed something that would work in this Drupal environment. So we went with Rust, because with Rust, what we can do is just compile it to an exe and have that run as a service on that web server, and it's not going to interfere with Drupal at all. And then for the documents, there's 2 main concerns we had for the documents. Was one, being able to serve the documents at high speed. So we didn't want any performance hit from what our old website has, which was just PDF files sitting on a file served through IIS. And then also, because some of these documents are very large, we needed to be able to support partial content, which is HTTP code 206, which we'll get into and look at a little later. So the website went live on September 23rd of 2019. We get about 220 raw requests per day, and that's not equivalent to page loads. It's like everything from the CSS to the images to the JavaScript files. And if you look, here's kind of the distribution. Is the images take up the most requests that we get. The second is the PDF documents. And the reason that's so large is because of the documents being served in parts, that 206 content. So one document that's a couple hundred megs might actually be 10 or 20 requests to the server to get the full document. Then we go down, it's the C# code that's being called, JavaScript, JS files, web pages, and then CSS, and then other stuff. We have a couple of Excel documents and audio files and so forth. So we get about 15,000 page requests a day. So it's not like the largest or most trafficked website. After all, it is just planning. It's the plan. So our department, so the city of Los Angeles is obviously a large organization. They have a large IT department, a large website. I work for the planning department, and the planning department has its own IT department, which is separate from the city of Los Angeles. And so our website is, even though it's in the umbrella of city of Los Angeles, it's separate from theirs. And so the planning gets a lot less hits than the actual city of Los Angeles does. So we get about 15,000 page requests a day, and we usually get almost as many document requests. So we'll get about 13,000 document requests, and there'll be some weeks if we have a new document that comes out where the document requests will even be more than the page loads. And that 13,000 document requests turns into about 30,000, segments of documents requested per day. So all the documents are on a Unix machine, which is 3.5 gigabytes, one CPU, and the Rust exe on there that serves the document uses very little of that RAM on that box. The majority of the RAM is used by OpenKM and Java. So recently I just updated the server and restarted it, but since then that server that's serving those documents has been up for 207 days with no visible memory leak. So the same amount of memory that it was using on day 207 was basically the same amount of memory that it was using on day 1. So the website went live in September. The month after it went live, the city of Los Angeles told us they were going to do a white hacking contest on our website so they could flush out any of the bugs. The city of Los Angeles paid for that. Every bug that they found, I think it was $10,000 or something they gave out. So we actually had 7 vulnerabilities that were identified and paid out. 3 of them were on classic ASPX pages. We do have a lot of old pages that didn't get converted over to the new Drupal that we use. And so there was old code on there that had some vulnerabilities that we addressed. We had 2 vulnerabilities on .NET MVC pages, which is newer code, but that application was managed by another group. So I really didn't get involved too much in that. We have Telerik Web URI, I don't know if you know about that. It's like a JavaScript components. We had a page that had one of their really old components on there that was outdated and had a vulnerability that they patched. But since nobody was maintaining that code anymore, we didn't patch it. And so it was identified and we just removed it. We also, on our fee estimator, we use dynamic PDF to generate the PDFs. There was a vulnerability in there with dynamic PDF that we were not aware of, that you can send HTML with JavaScript to generate the PDF, and that was a vulnerability. But now that entire application is in a WebAssembly app, so we don't even have to worry about it anymore. 0 vulnerabilities were identified on Drupal, and of course, 0 vulnerabilities were discovered on Rust. But the 2 web apps came after this, and the 2 static sites, which we get into, came in after this also. So those weren't involved in this. All right. In general, another type of attack is, we currently have an undercurrent of attacks coming from all over the world. It usually ends up being about 20 to 25% of our traffic. Every so often we get a targeted attack from Russia. They've always been from Russia when we've had like a targeted attack, and it usually comes from 1 or 2 IP addresses from Russia. And we can identify it based on the amount of volume of attacks. And usually the way we tell this is in our activity reports, which we generate from the Apache logs. Another type of attack that we have on our website is every weekend, the city of Los Angeles runs these QualSys automated attacks. And I actually just saw the reports for the first time a couple of days ago. And the only type of stuff that they've been able to identify, because when we had this white hacking contest, we basically addressed all the major stuff. They found everything and we addressed it. So now it's just, we have some old HTML pages that we'll get into that have some old JavaScript libraries that have some kind of vulnerability that, we'll probably address it, but it's minor. So then May 22, Bill Barr made his comment about the fact that started attacking verbally the city of Los Angeles for the mayor's wanting to keep the city shut down and locked down. And so Bill Barr came out on May 22nd and made his comments. Well, we come in Monday morning and Russia had launched a major attack on our website. And of course, everything is locked down, but we do have a couple of forms that send emails internally, and they got those. And so a couple of groups had about 700, 800, emails. They weren't phishing emails. They were more attacks trying to use SQL injection, but they weren't really attached to a database. So they just sent an email. But through all of these attacks, we have yet to come up with one Rust vulnerability that's been identified. Now I'm going to get into the actual website. And again, the main portion that is used by Rust on here is the documents. So let's take a look at some of these. So here's the actual website itself. This is all Drupal based, but when you get into documents, these are served by Rust. And so what's happening with these documents, which I'll show you in a second, is that OpenKM, it has a two-part system. It stores the basically the metadata of the PDFs, the text of the PDF. It pulls out, it extracts the text of the PDF. It generates IDs from them and so forth, the size of the documents, and it puts them into a database. And then all the documents themselves are stored by the GUID string in this file system. So what this Rust application does is when a request for a document comes in, it takes the GUID, looks into the database, gets the file location GUID, the size of the document, and then returns it back to the user. If the document's under 5 megs, which we'll see, it returns it directly to the user. If it's over 5 megs, it puts it into a Rust library called HTTP serve, which actually is able to render this partial content. So as the web browser requests certain parts of the PDF, this HTTP serve will send back just that part of the PDF. So you can load up, you can visually start seeing a PDF while it's still loading. So there's the document. This one's about 600K, loads very fast. I can't really, can I get this? Can I minimize this some way? Okay, let's see here. All right, I have to go like that. All right, so here's another PDF document. This one you see took longer, it's a larger document. I'm gonna have to go to shoot. All right, I have to go to this for the links. The links don't work on the. All right, so the mobility plan. This is a 54 megabyte document. You can see how fast it loads. So there's two ways to render the PDF documents. One is linearized or one is just the standard. This mobility plan document is standard. So that means Google or your browser will wait till the entire document is downloaded before it actually renders it. Linearized ones will start showing right away. This one is a 14 megabyte document. These ones will show right away, even while the rest of the document is loading. But as I was testing this today, I noticed that Google is actually, regardless of whether the document is linearized or regular, it's waiting for the full document to download before it shows it. So if I do this in Opera, you'll be able to see the document show while it's downloading. All right, that went really fast, so you didn't even get to see it happen. Anyway, so those are the documents. And so what I did to demonstrate this, this 206 content is I actually uploaded a video for us to look at. So here's a video being rendered by Rust.
Hello, and welcome to the virtual scoping meeting.
This video is being rendered by Rust, and you'll see that the video is playing while it's still downloading. And based on this HTTP serve library, I can jump to any point in the video and it will serve that part of the content. So it will stream, I can move back and forth. And when I chose this video, I didn't realize that it was basically slides, so you're not seeing any movement, so it looks like it's frozen, but
impact report,
you can hear that it's
EIR,
going based
which is
on
being prepared as part of the project.
Based on the audio. So basically what I'm saying is we have an actual Rust running library that's able to serve streaming videos. We don't actually use it for this because we have a third-party CDN that we use for videos, but we do use the same technology for the documents. All right. And then, all right. So now the Tantivy library that I was talking about, the web search. So if we go back to here, the web page, we have our little search function here. Every night we re-index with the Tantivy library all the documents and all the web pages. So if I did like a search for Mulholland, what you're going to get is all the web pages that have Mulholland in it, all the documents that have Mulholland in it. Now, we started using this Tantivy library a while ago before its highlighting was mature. So I had to actually manually write all the highlighting parts. But anyways, so this is, it does multiple, like if we did, you're going to get the ones that have all the words at the top, and then the ones that have less match going down. All right, so that's using the Tantivy library. Then the fee estimator. So the fee estimator is a WebAssembly. This is written in Rust, and it's a WebAssembly app. So this right here obviously is HTML. There's JavaScript in here that loads the WebAssembly app, and so this is a completely static site. So all of this, you'll see here that the fee estimate goes up. You can add different fees. It calculates it. The calculations are a little bit complicated, but this changes. You get an estimate. This is a completely static site. This runs from static files, one of them being a WebAssembly app written in Rust. And the Rust does all the rendering of the HTML through Mustache, a Mustache library, and renders it on the page. So now this is going to be really cool, and we will look at this later. So generating the PDF report, like I said, this is a static site. This PDF report is generated inside the WebAssembly app, and it's not generated on the server. So it's generated inside the browser. So this report, which is going to total the 2,000, will be generated all inside the browser. So it's got the image, special. This is the font. Roboto is the font that we use. It's our font for different colors and so forth. And we'll go over this. This is all generated in the website. So when we first launched this, this doesn't work with Internet Explorer. So I would get a couple of requests where people were like, hey, someone's having a problem using this. And I'm like, well, it doesn't work in Internet Explorer. I already knew it was a problem with Internet Explorer because this is a static website. So if someone was having a problem on their browser, then I would also be having a problem on my browser. There's no possibility that we have server problems because it's a static website. The events calendar, same thing. This is a Rust, let me find it. Where is it? Oh, here it is. Oh, events calendar, okay. This part up top is HTML. This is all Rust WebAssembly. And this HTML it's not calling to the server, it's being generated by the Rust WebAssembly. So 2 WebAssembly apps, and then we have a bunch of static static sub websites. And so these are kind of like old web content that they wanted put on the website. This first one, which we'll go over, is old content. They didn't want it upgraded because they didn't want people to think that this framework element had been upgraded. These 2 were done by a consultant a long time ago, and nobody had the source code and nobody knew where it was. I went to the Wayback Machine. I was able to track down the person who originally created it, who works for Netflix now, and she actually had the source code in GitHub. So, and these 3 sub websites are literally generated out of zip files. And so there's a zip file added to the project, which compiles into the exe. We're using the include bytes macro to pull that zip file and pull the relevant pages. So here's the first one. All right, so this is all Drupal, and then you get to this ugly, old-looking thing. This is basically those original HTML files. I just zipped them in, put them into, and compiled them into the exe, and they're being rendered through the Hyper app. So, like, even like this is a PDF. It's coming right out of the zip file. Relative links. This page is coming from this document in the zip file. So all these links work, and they're all coming from zip file. So then we have these 2 health atlas ones that were done by this consultant a long time ago that I tracked down, and those are right here. So here's one of them. These ones actually look pretty cool, but again, these are all static, coming out of a zip file, and this is all done in JavaScript. So all this stuff, I don't really know what it does, but there's one of them, and then there's another one right here, which is all coming out of a zip file, and then the JavaScript is doing all the motion and stuff. It's basically static files in a zip file. All right. All right, so the way we deploy these applications is we create a Rust exe, a regular exe using the Hyper library. Hyper listens over a certain port, gives you a request object. You send back our Hyper result object, and it handles all that. After we compile it, we add it into the systemd system, which basically makes it a web service, and then in Apache, we're just reverse proxying. So we are using Apache. The request comes into Apache, it goes to this Rust exe, it comes back to Apache and goes out. There's a couple of reasons for that. One, Apache will handle certificates. You don't have to worry about that, which would be kind of complicated. I mean, I'm sure you could do it in Rust, but it'd be kind of complicated. Apache does logging very good, and it also has load balancing. So here's the Hyper, the main part of the Hyper executable that generates, that delivers the PDF documents. So you've got your main function, right here I'm binding on port 5000 to any subnet. And basically what you're gonna pass to Hyper is a function. And here's the function right here. And the function takes in a Hyper request, and it sends back a box future Hyper result of a body, and the body can be anything. It can be bytes, it can be string. Those are the only 2 I really use. And so in the Hyper nomenclature, you have one function. So what ends up happening is in this function, there's like a lot of if statements, like if the path starts with this, then do this functionality. For the PDF documents, they all have a GUID. If you look, everything in the all the PDF documents, they have GUIDs. So they're this O document GUID, and so what we do right here, you use a regex. If the GUID matches, then it's a document, and then you do what you need to do to get that document, and you return your Bach future response with a body. Again, so I'm using, like we were talking about in the beginning, I'm using an older version of the Hyper library. I have not upgraded it yet. HTTP serve is what does all the 206 content. We'll see that on the next slide, and then regex and lazy static. So this is a more detailed version of that function. we get our GUID, and if the GUID matches, then we query the database, and then what we're going to do is we're going to get the file location in the database and the file size. If the file is less than 5 megabytes, just read the bytes in as a vector of U8, and then it just reads it as a vector of U8, and so we just set it as our body and return it. So this body, so response is a hyper response we're building. We put in the status code, the headers. The body is going to be a vector of U8 bytes, and just return it and return the future. If there's an error, write to the log. If the file's larger than 8 megabytes, what we do is I open a path variable, and I pass it into this chunked read file. And this is a HTTP serve chunked read file. And then when you do, what you do is it handles the process of returning the hyper request body based on the portion of the file that the web browser is requesting. And so every single time it's requesting a part of the file, it's going to go to the database, get the location. It's going to go to the database, get the location, pass it into this chunked reader. The chunked reader is going to figure out what part of the file the browser wants and returns it. So that's happening every time. So when we're streaming that video, that process was going on every time. So then what we do, this is the second part of taking the EXE and being able to deliver it over the web, is we put it into systemd. So what you do is you're going to create a file that's just a description. Very basic. It says what your EXE is. I'm putting in this Rust backtrace so that we'll get the error messages out to the log when they happen. You put your working directory, the name of it. This after means like we don't want our service to start until the MySQL service, till after the MySQL service starts. We're going to run this as root. And this just means that wait till someone is able to log in before using it. So all you really have to do to get your app into systemd is to create this file, put it in etc systemd system, and then to start your service, you're just going to call systemctl, start your app, systemtl, stop your app, or if you want it to be in the service so it starts on reboot, you'll put systemctl enable and then your app name. And then if you want to see the logs, it's journalctl - your app. Then what we do is, in order for it to be accessible to the web, is in Apache, we use the proxy and the proxy HTTP modules. And then all we do is proxy pass that subdocument to our Rust exe that happens to be listening on port 5000. So it comes in, goes to our Rust exe in port 5000, comes back and goes to the web. So the equivalent, this all is Linux based. If you wanted to do the similar type thing on Windows, what you would do is you would create a Rust exe that you could run as a Windows service. And I think there's libraries that you can include that will do that. And then what you do is in your IIS, you would just proxy to whatever port that service is listening on. Okay, I know I've kind of gone a little bit over. I'm trying to go quickly through this. So I'm going to quickly go through this setting up a WebAssembly and getting it to run. So I spent a lot of time trying to get WebAssembly to run, never had any luck, but then I came across seedrs.org, and it basically was a godsend. You just take their quick start project, you just do, cargo make start, and it runs the project. So that's what we are gonna see right now. All right, so I was gonna show this on this Windows machine, but cargo make requires build tools like all the GCC and all those build tools, and I couldn't get it set up on Windows. So we're gonna show this on the Linux machine right here. So if we go here, this is a very basic WebAssembly example. And so what we have here is Cargo Make uses their own TOML version of a Makefile. This machine's kind of slow. Very slow. All right, so then this is basically their different ways of making. So this Makefile handles generating everything you need for the WebAssembly. We have our basic HTML page that's going to serve it, which we'll see later. We have our TOML file, and for a very, very basic WebAssembly, the only thing you really need is the seed library. So all I'm using is the seed library in here. This we're using for a little bit later example. It has to be a C-style library. That's what this means. And then there's a huge difference between using this optimization and not in the size of your WebAssembly. So when you're doing a release, you want to make sure you have this in here so that the size of the file is not too big. All right. So I have a compiled version of this, and then we'll look at the, I'm going to go to the compiled version. I was going to show you that you could actually literally compile that basic project and get it to run, but I know I'm already over in time. So I'm just going to show it to you here. All right, so here's our C# code, C#, our Rust code. So basically you're going to use the seed library, and then you're going to use these WASM bindgen decorations and all your functions. And then all of this can be used as native Rust types. So you can see here, this function is actually returning a string. WASM bindgen and seed, they generate a JavaScript file that handles all the interoperability between Java and the WebAssembly. So we just have one function, two functions. Here's one that if you can also call JavaScript functions from within the Rust code. And so you have to put in this external C block, and then you put a reference to the Java code. All right, so basically, and to get this to run, all you have to do is cargo make start. And so if we look at the make file, start is down here, and basically where's start? No. Where's start? All right, so start is all it's going to do is it's going to build and serve, and it uses micro server, which is a small web server, small Rust web server to serve it. So we run this. All right, it's serving it over port 8000. So I'm going to just, because that runs slow, I'm going to run this over from here. Oh man. Hold on a second. Come on. There it is. $22. All right, so why didn't that go? Let's see. All right, so here's our example. We're gonna just basically put in some string. Oh, of course. Are you kidding me? Oh, okay. Let me fix that. So all right, so in here,
Classic. It never works when you're trying to show people, eh?
no, I know. And the thing is I was going to add in this MD5 function after, but I guess I didn't take it out everywhere. And then this virtual machine is running real slow. Where then? Hold on a second. Oh, you know why? I might have to. Let's see. All right, there we go. It was cached. So when these compile, it creates your WebAssembly, and it also creates a JavaScript file, and they get cached. So if we look at this function, that's one function. Here's another one. And then we have this one, which is the write to console. And what we'll see is that one was written to console. So if we go back here, these are the actual functions. Here's the main function, and it's hello plus whatever input string. And then the second function is takes a string and says goodbye, and then the string. So these functions are created in Rust. They're compiled to the WebAssembly. And then what you do in your HTML file is you have to actually import all of these functions from the JavaScript file that's generated. All right, so you see here, I'm importing the main JavaScript file that was generated by Wasm Bindgen. So we're importing these three functions that we have there. And then since all of this, the WebAssembly stuff has to happen in a JavaScript module, you have to specifically put it on the window for it to be a general function. Okay, so what I'm going to show you. All right, so what happens when this is generated is that in this package folder, you get your actual WebAssembly. This is the actual WebAssembly. And then this package JS is the one that has all the binding to the WebAssembly. So this is all generated by this seed library. So if you look, if I look for the function, so here are the actual functions, and here's all the JavaScript that happens to call the different functions in the WebAssembly file and so forth. And this is all auto-generated by the seed project. All right, so one last thing is we're gonna generate this PDF document in the browser, and then I'll be done. I know I'm like way over. I thought I'd be able to fit this all in. So we'll just show you this. Because that other stuff, it's just basically, you know, text. And so this is a little bit more involved. You see a little bit more Rust code. So in this example, what we're doing is we are, again, passing in a string that we're going to put in our PDF document. So this is the basic PDF document here. Here's where our text is going to go. Luckily, this is a very easy PDF document, because when you start editing all these things, all these objects, they have to be in their very specifics. Here you have to identify exactly where in the file each object is. And we're only working with object 4, which luckily happens to be the last object. So the only thing that we have to change here is where this thing starts. So what we're doing here is the string comes in, I'm replacing it here, which actually writes the string. I'm also writing this out because I got this PDF document from this website. So I'm writing this out at the bottom. And then we have to adjust where the xref starts based on the size of the text we put in here. And I'm just basically doing a find to see where that is in the document. And then we're doing a replace, and then I'm sending back the bytes. So this is very cool, is with the WebAssembly, you can send back this, obviously a vector is very Rust, a byte array would be more general than actual vector, but this is actual Rust code, but this seed library will generate that JavaScript that handles it. So if we run this, okay, and all right. It's a good thing I thought I hadn't pre-compiled these. All right, so that's running. It's the exact same place. I'm going to do a Shift F5 so this reloads. And here's our generate PDF. We're going to put some text in here. We run it. This PDF generated by that Rust code in WebAssembly. And here's where I put the credits to this. So basically, we are, and again, if I change the text to something else, the text changes, obviously. All right, so there it works. And basically, again, what we're doing here is we are, I'll just show it right here. Here's the JavaScript. So we are, so we're basically sending our text into this get PDF bytes function, which is this function right here. And then we are sending that to show PDF. And show PDF is just a bunch of JavaScript that opens the binary in, where is it? Oh yeah, here it is. So here's show PDF. So it takes in the bytes, it creates this blob with what type it is, and then this URL, which is this is all JavaScript stuff, it's a JavaScript library. This revokes the URL if we already had one. It creates a URL based on the blob, and then we're just doing a window open with the bytes, and it opens it in a new window. And so we can actually like call this from here too. So if we wanted to do get PDF bytes, here it is, because we added it to the window. All right, so if we have a variable, so this is actually coming from that Rust code. And then if we wanted to show it, it would just be show PDF, the bytes, and it opens it in another web browser. And that's it.